human eye, colorful world, human eye, colorful world, colorful world. Here, this is a human eye, colorful world. So I explained a few topics in the previous classes. So topic number one, least distance of vision. This is a LDDV. LDDV. Least distance of vision. So next let's see angle of vision. Angle of vision. So what is the meaning of angle of vision? Already explained to you. So next term, human eye. Human eye. Construction of human eye. Construction of human eye. Say human eye also. This also I explain this concept also. So next one is defects of eye. Defects of eye also it is over. So here LDDV, least distance of distant vision. Here is a healthy person's human beings. They have 25 centimeters, and below 10 years they have the LDDV is 8 centimeter to 7 centimeters. Oldest people they have the LDDV value is 1 meter or 2 meters. 1 meter or 2 meter. Angle of vision is healthy person 60 degrees. Below 60, we are able to see the clear full part of the image, full part of the object. So above 60 degrees means we are not able to see the full part of the object, full part of the object. Next, construction of eye already explained to you in eye. So we have the parts of the eye. So cornea, lens, iris, ciliary muscles, pupil, so retina, optic nerve. We have this is a parts. You have to learn structure of eye in your book. But once again we are studying in physics classes. Construction of eye, what we have to learn in this. You have to learn in this eye is mechanism of eye you are studying. So you know very well ciliary muscles. What is the use of the ciliary muscles? Suppose ciliary muscles means what is a ciliary muscles? What is the use ciliary muscles? How the cornea? What is the use of? What is the function of cornea? Cornea means that is I have the one outer port layer. Outermost part of the layer is called as cornea. What is the function of cornea? It allows the light. That is a cornea. So next one is iris. Iris means so we have the muscles diagram. The circular muscular diaphragm is called as iris, and one small circle is at the center of the iris that is called as pupil. That is a pupil. And what is the function of iris? Function of iris.
Sir, KSR sir. Sir, unmute channel sir. Unmute channel sir. Unmute.
Hello. Eye colorful world chapter. We are in the human eye colorful world. So we have the subtopics that is LDDV. LDDV means L means least, D means distance, D means distant, V means vision. We have healthy persons, some healthy persons, they have the 25 centimeter LDDV. Below 10 years, they have the LDDV is 7 centimeter to 8 centimeter. And old people, they have the LDDV values 1 meter to 2 meters. And angle of vision. Angle of vision means healthy persons, they have the 60 degrees. Suppose below 60 degrees means so we are able to see the whole object. Above 60 degrees means we are not able to see the full object. Full object. Constriction of eye. Constriction of eye means we have the parts cornea, lens, iris, pupil, and retina, and optic nerve. We have the different type of parts. Cornea means this is the outer part of the eye. Outer part of the eye is called as cornea. What is the use of the cornea? What is the function of cornea? Means it allows the light. It allows the light. Next, lens. So we have the crystalline lines. Crystalline lines that is held by the ciliary muscles. Held by the ciliary muscles. Next, iris. It is a you are seeing to the we have the eye in the dark, circular dark, large circular dark is called as that is iris. Iris having the one iris having the center point one circle is there, that is called as pupil. The pupil. What is the use of what is the functioning of iris? What is the functioning of iris? Means iris will control the size of the pupil. Size of the pupil. Iris controls the size of the pupil. Size of the pupil. Suppose, for example, so we are in the dark room. We are not seeing any object, but after 1 or 2 minutes, we are able to see the object. But what is the reason? Means we're in the dark room. Means so there is no light. There is no light. Less light falls on the eye, but iris will control the pupil size. Pupil size. Iris will expand the size of the pupil. Iris will expand wide range of the pupil. So more light is allowing the people, and we are seeing to the object. Suppose, for example, we are seeing to the sunlight. We are seeing to the sunlight means more light falls on your eyes. But but in this situation, iris will control the size of the pupil. Size of the pupil decreases by the iris. Size of the pupil decreases by the iris, and the less pupil allows the less light. Less light. That is a functioning of iris. Okay. Suppose we are in the dark room. Dark room means less light is present in that room, and the size of the people dig size of the people size of the people is increases by the iris, and that people allows the more light. After 1 or 2 minutes, we are seeing to the all objects in the room, dark room. And suppose, for example, we are seeing to the sunlight, and more light falls on the eye. So, but in this time, the size of the pupil decreases by the iris. The pupil allows the less light. That is the functioning of iris. Okay. Next, retina. What is the use of the retina? So, formed by the lens on the retina, and retina having number of retina having millions of rod and cones, and retina having rods and cones. What is the use of the rods and cones? Cones means it identify the colors, and rods means it identify the intensity of the light, And here, eye and brain. Every person have the eye and brain, and the connection between and the optic nerve. One part of the optic nerve is connected to human eye. Another part of the optic nerve is connected to brain, and any electrical signals are transferred from eye to brain through the optic nerve. So any electrical signals are transferred from eye to brain through the optic nerve. And the next, that is construction of human eye. Suppose, for example, next ciliary muscle. What is the use of the ciliary muscle? Suppose I'm standing here, I'm seeing to the large distance, but ciliary muscles are relaxed. Eyelids become thinner. Eyelids become thinner. Image formed by the lens on the retina. So next, I'm seeing to the very near object. Ciliary muscles will become ciliary muscles will compress to the convex lens, and the size of the lens became larger and wider, and the image formed by the lens on the retina. That's why, so we can see the image. We are able to see the image. That is a functioning of ciliary muscles. And changing the focal length of the convex lens by the ciliary muscles is called as accommodation of eye. Accommodation of eye. What is the meaning of accommodation of eye? Means accommodation of eye. Changing focal length of the convex lens by the ciliary muscles is called as accommodation of the eye. Accommodation of eye. So, okay. Next, we know very well a common point. What is a common point? Distance between and retina and lens is that is a 2.5 centimeter. That is a fixed value. But the object is position of the object is different. But image formed by the lens on the retina is distance between lens and the retina is 2.5 centimeter. That is a fixed value. That is a fixed value. Fixed value. So, what that is so in the previous class I explained I explained. So what I explained. So position of object is placed at infinity. Image form on the retina. So object is placed behind the center of curvature. Image formed between the 2s2 and C2 and F1. But the object is placing center of curvature. Image form on the center of curvature. Object between the center of curvature and sub-focus image formed behind the center of curvature, and object is placing on focus image will be formed in infinity. But here in the previous class I explained focal length does not change, but position of the object is moving towards the lens, and image is moving away from the lens after it will reaches to the behind of the lens. But here, but in a specify, we are seeing to the long object, but the image formed on the retina. But the distance between the lens and retina is 2.5 centimeters. That is a fixed. But what is the change of here? What is the change means here? Eye lens is able to change. Eye lens is able to change. Here, focal length of the lens is changes by the ciliary muscles. That is a God is given gift us. Okay, defects of eye. So when we are getting the defects of eye, for example, so focal length of the convex lens changing by the ciliary muscles. So maximum is 2.5 centimeter, minimum is 2.27 centimeters only. So object is placing between far point and near point. So far point and near point, the image will be formed on the retina by for changing the focal length by the ciliary muscles. So that is a main point. So object should be placed between uh, far point and near point. Object should be placed between far point and near point. Image formed by the lens on the retina, and focal length of the convex lens changing with the ciliary muscles. Okay. So what is the maximum focal length of the convex lens? 2.5 centimeter. So what is the minimum focal length of the convex lens is 2.27. Suppose, for example, object is placing behind the far point, and object should be placed behind the after the near point. So we cannot see the images. So we are getting the defects. The defects is so we have the defects is what is the defects? That is one is myopia. So another one is metropia. So we have the problem. So third one is presbyopia. So we have this is a problem. So this is a generally uh, so generally it's young people, so they're getting, and this is young people, so they're getting these problems. And hypermetropia, aged persons, so they're getting the hypermetropia. This is a aged person, so they're getting maybe chances both the combination. This is a combination. We are getting myopia and hypermetropia. Chances, maybe chances. So what is the myopia? This is we call near sighted. Suppose, for example, I have the myopia. Suppose I'm removing my specs, I cannot see the large distance. But without specs, I can see the near objects very clearly. But without specs, I cannot see the long object. long objects. So suppose, for example, I'm wearing the specs, I'm able to see the near distance as well as I'm able to see the long distances. This is a myopia and connected with the myopia. So how can we correct the myopia means so we are by using concave lens we are using concave lens we are using. So this is a hypermetropia. Hypermetropia. So yes, persons so they are getting hypermetropia. Yes, persons they are getting hypermetropia. So they are able to see the long distance, but they are not able to see the near distance. Near distance. But how can we rectify this problem? Is by using convex lens. Convex lens. They are using convex lens means so they are using the spits convex lens means they are able to see the long distance as well as they are able to see the near distance. Problem is rectified. So this is a presbyopia, maybe chances. Suppose for example, age persons they are getting the chances hypermetropia. Hypermetropia. In suppose they are 14 years and to 12 years in 30 years, they had already myopia means they are in the 40 years. Maybe may or not they are getting hypermetropia. Hypermetropia both combination. This is a both combination presbyopia. Okay, so they had this they had myopia and hypermetropia. How can we correct means by using the by bifocal bifocal lens. Focal lens. We are using bifocal lens by using. Okay, so yeah, they had how can we correct this one means this is a this is a concave lens. Concave lens they are using. Down part is they are using is a convex lens. Convex lens. Upper part is a concave lens. Lower part is a convex lens. They are using. This is a specs they are using. This is a specs. Okay. So this is a glass. This glass can be divided into two portions. Upper portion is made up of concave lens. Lower part is made up of convex lens. Convex lens. So if any person they have the two problems means that people should be so where this specs they are able to see the long distance as well as near distance they are able to see that. So so we can so presbyopia. How can so we can rectify presbyopia means by using the bifocal lens. Bifocal lens specs can be divided into two portions. Upper portion is filled with concave lens, the lower portion is filled with the convex lens. So we can rectify this problem. Rectify this is a problem. Okay, now the next I'm going to explain defects of eye. This is overall. The next is power of lens. Next topic is power of lens. Power of lens. Power of lens. So what is the meaning of power of lens? It is denoted by the field. It is denoted by the field. Very simple definition. P is equal to 1 by. P is equal to 1 by. This is a focal length of the convex lens. This is a P. P indicates it is denoted by the P. Power of lens. Power of lens. It is denoted by the P lens. P is equal to 1 by F. 1 by F means focal length of the convex lens. Focal length of the convex lens may be focal length of the concave lens also. So this is a power is equal to reciprocal of focal length. Reciprocal of focal length that is a power of lens. Power of lens. This is a 1 by F in meters. This is a meters. This is a P is equal to 100 by F centimeters. Yeah, centimeters in the centimeters. So SI unit of SI unit of power. SI unit of power. Power means that is a diopter. Diopter. Let's write. So this is a let's write capital D. Capital D. So the diopter. This is a diopter. Diopter. This is let's write small d. So we can use a small d. Small d. This is a we can use a small d. Small d. So we can use small d. That is a letter small d. Small d. This is denoted with a small d diameter. This is a power of lens. Power of lens. This is a focal length. This is a focal length. So focal length means focal length. So suppose for example, this is a focal length. Focal length. Focal length. So this is a power of lens. So power of lens. Here you are seeing. Suppose for example, suppose so this is a for example this is a focal. So P is equal to P is equal to 1 by F. 1 by F. F means focal length. F means focal length. Focal length. Suppose for example F means focal length. So we can use convex lens or concave lens. Concave lens. You're seeing to that this is a convex lens. This is a size you are saying. This is a lens. You see what is the difference between this is a you see this is a lens. This is a lens. Here, what will happen in this situation? In this situation, suppose this is a ray travels parallel to the principal axis. This is a ray travels parallel to the principal axis. Principal axis. This is a ray travels parallel to the principal axis. Principal axis. So what will happen? So this is a convex lens. It is a convergent. It is a convergent. Suppose, for example, it is a convergent. So this is a 2F2. This is a F2. This is a F1. This is a 2F1. This is a 2F1. So this is a ray travels parallel to the principal axis. Actually, there is no lens. The ray it goes straight. The ray it goes straight. So, but here lens is present. This light ray travels parallel to the principal axis. Strikes convex lens. It is a convergent. It passes through the focus point. It passes through the focus point. This is indicates this is a power of lens. Power of converging power. Converging power. Converging power is less. Converging power is less. For in case, for example, this is a convex lens. Convex lens. So this is a C2. This is a C2. This is a F2. This is F1. This is a C1. C1. This is a light ray travels parallel to the principal axis. Parallel to the principal axis. Parallel to the principal axis. It is convergent. It is this is a light ray travels parallel to the principal axis and strikes convex lens. Convex lens. Suppose there is no lens, it goes straight. There is no lens means there is lens is absent. The ray goes straight. The ray goes straight. Lens is present means it is convergent through the this one. So you see the difference. This is a power of converging lens. This is a power of converging lens. This is a converging. You see the converging. So this is a thin lens. This is a thicker lens. Thicker. So power of converging here, power of converging, you are seeing to the power of converging. Power of converging. This is a power of converging. So power of lens means P is equal to 1 by F. 1 by F. P is equal to 1 by F. P is equal to 1 by F means so focal length increases means power is less. Suppose focal length of lens is decrease means power is more. Power is more. Power is more. You are saying the power is more. Power is more. Okay, you can understand like this. So focal length is less. Focal length is less means power is more. So focal length is decreased means focal length of lens is more means power is less. Focal length is decreased means power is more. Power is more. This is a power of lens. Power of lens. This is a very important this unit. Very important. SI unit of power. SI unit of P is a diopter. Diopter, it is denoted by the small d. It is a very important. So this is P is equal to 1 by reciprocal of F. This is a meters. P is equal to 100 by F centimeter. In centimeters, in meters, this is the diopter. That is a SI unit of the diopter. SI unit of the diopter. Okay, keep in your mind. That is a keep in your mind. So next problem. So based on this question, so we are going to solve the problem. We're going to solve the. So example number 1, example problem, example number 1. So what is given here? Doctor advised to use 2D lens. Doctor advised to use 2D lens. 2D lens. So what is its focal length? Focal length. This is a question. That is a question. How can we solve this one? Power of lens. Power of lens is equal to. So P is given 2D. That is a 2D. So next, what we have to find out? Focal length. So we have to find out the focal length. So but what we have the formula? P is equal to 1 by F. This is SH. So P is equal to, what is the value? 2D. 2D. This is a F. F take this side. F is equal to 1 by 2D. 1 by 2D. This is your focal length answer. Focal length answer. Focal length in answer. So in this is a centimeters we are taking. Suppose we are taking the centimeters. Suppose in the centimeter. I need to calculate in the centimeters. Centimeters. I need centimeters. So I need centimeters means this is F centimeter. F centimeter. How can we calculate the F centimeters? This is a 2D is equal to 100 by F in centimeter. F by in centimeter. F in centimeters. How can we calculate this one? So F is equal to 100 by 2. This is a unit small. Don't take this is a unit. This is a unit. This is a 2 ones 250. F is equal to, so what is a 50 centimeter? This is a 50 centimeter. This is a your answer. So length of focal length is 50 centimeter. This is a S unit of power. But so it is what is its focal length? Focal length we have to find out in a centimeter. That is a question mark. So next question. This is a over. That is a over. Next lab activity. I'm going to explain lab activity. Next example number 2. 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 Exercise. So a prism with a prism with an angle A is equal to 60 degrees produces an angle of minimum deviation of 30 degrees. So find the refractive index of material of the prism This is a question. This is a given question. How can you find out this answer? Okay, find out. Okay, find out. Given data. So what is a given data? So given data is a prism with an angle. ASK. This is angle of prism or refractive angle of prism we are calling. An angle of deviation. Deviation del is equal to or D. You can take letter, whatever letter, that is a D or del. So we are taking that is a capital small d and that is a 30 degrees. So find the refractive index of the material of the prism. This is a and indicates refractive index of the prism. Refractive index of the prism. This is a question mark. That is a question mark. Okay, well, we have the formula. What is the formula? So refractive index of the formula. So n is equal to sine d plus a by 2 sine a by 2. That is a formula we have. This is a formula. In this formula, n is equal to sine d plus a by 2 sine a by 2. A by 2. Here n is equal to sine of d means 30 degrees, a means 60 degrees by 2. So here sine a means what is the a value? 60 degrees by 2. So we are simplifying this one. Sine 30 plus 60, 90 by 2. 90 by 2. Sine, this is a 2 and 2 ones, 2 30 is 60. Here 2 ones, 245. This is a sine 45. So here n is equal to sine 45 1 by root 2 by sine 30. So that is a 1 by 2. 1 by 2. N is equal to 1 by root 2 into this is a 2 by 1. 2 can write root 2. And root 2 into root 2 means that is a true value. Okay, na? So we are going to write this is a 2 root 2. 2 root 2 cancel means finally n is equal to root 2. This is a refractive index of the prism. That is your answer. That is your answer. Your answer. Your answer. So that is your answer. This is a refractive index of the prism. Refractive index of the prism. That is next activity 3. Lab activity. Next lab activity. Next concept is lab activity. Lab activity. Lab activity. So lab activity. lab activity. So next concept is lab activity. Lab activity. Lab activity. Lab activity. So aim is find out refractive index of prism. Refractive index of prism. So refractive index of the prism. Find out the refractive index of the prism. This of prism. Material requirement. Material requirement. Some material requirement. MM means material requirement. Requirement means M. Some material requirement. I need prism. Next, I need one prism. I need prism. Okay, you see the prism. I'm taking here prism. So this is I'm taking a material required prism, white chart, and drawing board. First of all, okay. So here find out refractive index of the prism, refractive index of the metal. So we consider drawing board next to white chart, next to prism, next to pencil, scale, eraser, and pins. So this is a clamps also we need. This is a metal required. So what we need? So first of all, so we consider drawing board next to sheet, white sheet, prism, glass prism. It is made up of any so, glass prism. Next, pencil, scale, protector, pins, and clamps. This is a so after we collected all these materials, what we have to do means first of all, this is a board. It's a board. So you take the white paper, that white sheet, place over the drawing board. The paper is not moving away from the board. What we have to do, we take this clamp attaches to the board and paper. So finally, so the paper is very tight. The paper is attached to the board by using the clamps. Next, we have to draw the border lines with the help of the pencil, scale, and next the prism places on the middle of the paper. So this is a prism. So prism placed on the middle of the paper. This is a prism. So prism placed on middle of the paper. So next we have to draw outlines of the prism. So we are drawing the outlines of the prism. Outlines of the prism. This is outlines of the prism. And remove the prism. So prism removes from this paper. So you are seeing this is outlines of the prism. This is a point. This is a P point. This is a Q point. This is a R point. So next, so we take the protector, the protector placing here, and the protector having this is a normal, this is a 90 degrees. So protector keeps on PQ plane of the prism, just to we mark the normal line. So we mark it, and so what we have to do just to you mark it. So you take this point and this point, and you take the scale. The scale keeps here. So we draw the perpendicular. We draw the perpendicular. We draw the perpendicular. We draw the perpendicular. So we draw here perpendicular. We draw perpendicular. So we draw perpendicular to the surface, PQ surface at a point M. This is a point M. And place the protector along the PQ line. PQ line, you mark the 30 degrees. You mark the 30 degrees. So light ray strikes at this point. Light ray, this is a light ray. So light ray, this is a light ray falls, strikes the PQ surface of the prism. PQ surface of the prism. So we call this is incident ray. We call incident ray. This is a normal line. This is a normal line. This is an incident. This is an angle between I and N. We call this is an angle of incident ray. Angle of incident ray. So this is a point is M point. M point. Light travels from. This is a radar medium. This is a denser medium. Light travels from radar medium to denser medium means, you know, this is a light travels from radar to denser, radar denser. This is a light is traveling towards another medium. This is actual direction of light. This bending towards a normal. So this is a light travels from denser to radar medium. This is a light is traveling towards another medium. It is not moving straight. It is moving away from the normal. This is I. This is angle of I. This is angle of R. This is R. This is R. This is angle of I. This is I. This is angle of R. Okay. So yes, that is a point. That is a point you are saying. Okay. Now see. You see, light travels from radar to denser. This is a normal line. This is a normal line. This is a refractor. So now light travels from radar to denser. This is a normal line. This is a bending towards a normal line. This is a bending towards a normal line. This is a refractor. This is the angle of R1. We are checking. This is I1. So we are taking. This is a ray. So light strikes at this point. This is a light is a refracted M point. It is moves through the prism and it is reaching to the another plane of the PQ surface. At this point, this is we are taking N point. Again, light travels from this is a denser medium. This is a rare one. Denser medium, radar. Denser, radar medium. Okay. Now wait 1 minute. Now, so we are checking. So here, this is up to 1 minute. Wait 1 minute. So this is outlines of the prism. So we draw the normal line. So, and protector is placing here. So we mark the DR 30 degrees. 30 degrees. This is an incident ray. This is a normal ray. And so you take the two pins. The pin. So one pin is this is a P. This is a A pin. Pin A is inserted in this line. This is a B pin. So B pin also inserted. This is a what line? So this is a AB line. So we are taking this is a AB line. This is a M point. We are taking N point. Okay. This is a X, Y. This is we take the PQ. No, already I taken the PQ. So this is two pins mark here. Okay, don't take the any points. This is a two pins. Two pins, two pins attach the AB line, AB line. Now we take the prism is placed. So prism is placed, placed placed on its prism is placed on outlines of the outlines. Okay, now prism is present. Prism is present at this place. Prism is present means I'm seeing to here. This is a line. Okay, so prism is present to here. So now prism is present here. I'm seeing here. I'm my eye keep here, and my eye is keep here. I'm seeing the pins. Yeah, two pins there, two pins. My eye keeps this side of the prism. This side of the prism. Two pins are left side of the prism. My eye keep right side of the prism. Right side of the prism. Now I'm seeing to the two pins through the prism, and now two pins are placed the right side of the prism, left side of the prism. My eye keep left side of the prism, and I'm seeing to the two pins through the prism. To the prism, I'm marking. So I'm taking the two pins here. This is the two pins marking at this line. So this is a we mark here. Now this is a 1, 2, 3, 4. Four pins are in the straight line. Four pins are the straight line. So when prism is placing here, I'm seeing to the four pins are in the straight line. Four pins are in the straight line. Saying next to this is a prism is removed. So we join the lines. Okay. This is a light travels from radar to density. It is bending towards the normal. Again, this is a light travels from, we draw the normal line at this point. This is a point again, and this is a emerging line. This is actual direction of ray. Actual direction of ray. It is bending away from the normal. We are checking away from the normal. You see? So this is a point. So you are this point. The light goes this direction. This is a direction. The light goes this direction. Okay? You are seeing to this one. Now this is a pin 1, pin 2, pin 3, pin 4. All are in the same direction. Pin 1, pin 2, pin 3, pin 4 are in the same direction. All are in the analogous cycle. So prism is placing here. Two pins attached along a AB line. So two pins are stick on the outlines. This is a CD line. So CD line. Okay. So three lines are like. Suppose prism is placed on this. Prism is placing on outlines of the prism. Now I'm seeing the two pins. I'm seeing to the two pins that say through the prism. I'm seeing the four pins on the straight line. Now prism is removed. So this is a light ray. This is a light ray goes this direction. Suppose there is no prism, means this light ray goes straight. This is a we call emergent ray. This is emergent ray. So this is a emergent ray. See here, angle between this is a normal line. We call angle of emergence. This is we call incident ray. Angle between and N and I means this is angle of prism. Angle of incident. This is we call angle of prism. This is a angle of prism. This is actual direction of incident ray. This is a emergent ray. Emergent ray extends the backward direction into dotted lines. Okay, you can extend. This is the angle between. This is angle between. So this is an incident ray. This is emergent ray because this is a deviation laterally it is denoted by the del, or it is denoted by the small d. Small d. This is angle of deviation. Angle of deviation. Angle of deviation. Angle of deviation. So now in this case, in this case, so now in this case, this is a incident ray, this is a deviation. Now when we are getting the minimum deviation, so minimum deviation, minimum deviation. So when we are getting the minimum deviation, so when we are getting the minimum deviation, E is equal to E. So this is I. This is the angle of incident ray. Angle of incident ray is goes on increases. Angle of incident ray goes on increases. Angle of emergent ray goes on decreases. Angle of incident ray increases, and one particular angle. So this is the angle of incident ray. This is the angle of emergent ray. Angle of incident ray is goes on increases. Angle of emergent ray goes on increases, decreases maybe. So one particular angle of incident ray is greater than 2 angle of emergent ray. That's how we are getting minimum deviation. So this is angle of incident ray. Angle of incident ray goes on increases. One particular angle of incident ray is equal to angle of deviation. Both are equal. That's how we are getting minimum deviation. Minimum deviation we are getting. So minimum deviation we are getting when the time. So when we are getting minimum deviation means angle of incident ray is goes on increases. One particular angle of incident ray is greater than 2 angle of emergent ray. Both are equal. That's how we are getting minimum deviation. Minimum deviation we are getting. Minimum deviation we are getting. That is a condition. Minimum deviation. So next time, next you see the graph between. So we see the graph. So this is angle of incident ray. So this is a deviation. Angle of deviation. Angle of deviation. Angle of incident ray goes on increases. Angle of incident ray is goes on increases. Angle of deviation is first decreases. Angle of incident ray is increases. Angle of incident ray is goes on increases. Angle of incident ray increases. Angle of deviation is first decreases. It reaches to the minimum value. Minimum deviation. After angle of incident ray is goes on increases. Angle of deviation also goes on increases. One particular value. So one particular angle of I is equal to angle of E. At this place, so we are getting minimum deviation. This is an angle of incident ray goes on increases. Angle of incident goes on increases. Angle of deviation goes on decreases. And it reaches the minimum value. After angle of incident ray goes on increases. Angle of deviation also it starts increase, goes on increase. This is a graph. This is a graph This is a graph between. So this is a graph. So this is angle of deviation is along x-axis. Angle of incident ray is along y-axis. So this is a graph between minimum deviation. So this is a graph. This is a very important graph. This is a lab activity. So this is we have to do find out the refractive index of the prism. This type of lab activity we have. This is a practical we have to do in the lab. So you are getting the more clarity. So we collect some values. So we take angle of incident values and angle of deviation, and we are finding the refractive index of the prism. How can we find out the refractive index of the prism? Means n is equal to sine a plus d by 2 This is a sign A by 2. This is a n indicates the refractive index of the prism. Refractive index of the prism. Okay. So we connect. This is a A. This is a angle of prism. This is a angle of prism. D means deviation. This is a deviation. A means angle of the prism. All values collected from this practical values. That all practical values put in this equation. We are getting the angle of the prism. Okay. Thank you. Thank you very much. This topic is over. Tomorrow I will start the new topic. Thank you. Thank you very much.
అప్లోడ్ చేశారు అప్పుడే ఈ రోజుకి ఇప్పుడుది అప్పుడే పోరం okay Nana, today now I am going to example 3. Today now I am going to example 3. What I am asking? Find the zeros of a quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and the coefficients. Okay, Nana? What I am asking in this one, find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between zeros and coefficients. First, I will take the given quadratic polynomial, that is x square plus 7x plus 10 is